Hello, everyone, and welcome to today's webinar focused on product lifecycle and local assembly. While we wait that you all join the webinar, I'm going to ask to mute. Yeah, so everybody's muted now, so there are no background noises. I'm going to give one more minute for everybody to join. As internet sometimes is a little bit slow, we need some extra time. So sorry for those who were on time. So I was saying that I am Jackie Garcia and I'm part of the Efficiency for Access Design Challenge team and the facilitator of this webinar today. As a reminder, these webinars are designed for participants of the Efficiency for Access Design Challenge, which is an initiative led by Efficiency for Access with support from Engineers Without Borders UK. This webinar is being recorded and the cameras and microphones of the attendees are disabled, except for those of the main speakers. But you all can use the chat box to make any comments or the Q&A section for questions for our speakers at any time, and we discuss them later on. Hopefully you can locate the chat box and feel free to share any comments and questions. Hopefully you can hear me well. Let me start with the agenda for this webinar for the product lifecycle and local assembly. So we will have 3 guest speakers talking about the product lifecycle, e-waste, and local assembly. Then we will have space for Q&A, questions and answers, and then we will share a short webinar feedback to collect some of your comments on the webinar. Before introducing our guest speakers, I would like to ask the audience some questions. We have students and academics from different universities and countries attending today, so I'm interested to know the general understanding of these topics and your previous exposure to these themes, either at an academic level or from a personal interest point of view. So the first question for the attendees is, how would you rate your current knowledge on product lifecycle? You will have a pop-up window where you have the question and different options to respond. So you can say, excellent, I know a lot about the topic. Okay, I know a little and I want to expand my knowledge. Not much, I want to learn more, or nothing at all. I don't know what the product life cycle is. So you can just answer what is more accurate for you. There are no right or wrong answer, excuse me. It's only just to gauge general feeling on that. So it looks like 60% of you, you have an okay knowledge, but want to expand your what you know already. So the second question is, does your current course or degrees curriculum include product lifecycle subjects? Yes, no, or I don't know. Should be pretty straightforward. Okay, so poll is moving, responses are arriving. It's moving a lot. Okay, it seems like we have 33% that yes, you have some kind of exposure to through the current course or degree that you are studying. 44% doesn't, and 22% doesn't know. It's okay. I mean, we will learn some things today. So now let me introduce the speakers. We have, Mr. David Tusubira. It's a tech entrepreneur. Currently is Chief Technical Officer and co-founder of Innovex, using Internet of Things technology to promote access to solar energy in sub-Saharan Africa. Excuse me. Mr. Tusubira holds a bachelor degree in electrical engineering from Makerere University, hardware developer with a background in robotics. We have also Dr. Laura Allerston, is head of grants and research at Acceleron and concentrates on grant funding opportunities to enable development of R&D efforts and scaling project work in Africa. She has a PhD in chemical engineering from the University of Birmingham, with work also completed in the IIL at University College London, which focus on hydrogen fuel cells and electrolyzers. Sounds very exciting. Mr. Viraj Gautam, Mr. Viraj Gautam is the Chief Executive Officer of People Engineer and Energy and Environmental Development Association, PEDA. He brings more than 12 years of professional experience in management leader and an environmental professional. He has extensive work experience as an environmental energy practitioner on various research and development projects related to hydropower development, rural electrification, solar wind hybrid system, electric cooking, etc., etc. Mr. Gautam holds a Master's on Science in Environmental Science from Tribhuvan University in Nepal. Now, without further ado, David, the floor is yours for your insight on the topics.
Hi, everyone. Happy to be here and happy to have everyone that has attended. And also, I'm glad for the opportunity. I hope you can hear me properly.
Yes.
Great. So, as Jackie already introduced me, I'm CTO of Innovex, a company that has been in business for about 5 years, and our core business is manufacturing of IoT devices that are used for remote monitoring of off-grid solar systems, off-grid PV solar systems. So right from the beginning, we've been involved in the design and production of particular hardware device. And so hence my being here, I guess. So talking about the three things, as product lifecycle, e-waste, and local assembly, the best I can offer you is my experience. So as any product, our device, which is called the Davix, named after me, first starts with the first phase, which is the introduction. So we designed the product and we made the first prototype, and we identified a pilot testing partner that was a solar company, and they bought the first unit and we installed it on one of their solar systems. And this was the first time they ever experienced getting real-time data from a solar system that's installed somewhere far away. They had never experienced this, and the reason why they wanted this was because solar systems fail, and as a person who has installed a solar system or has sold a solar system to a customer, could be a hospital, school, or an individual in the home, you want to know why it failed as the person who provided this, because you want to offer better services. So it was a great experience for them, but the product actually failed a couple of times, and the same piloting company gave us an opportunity to install more hardware, more solar systems that are up country, and with that practice, we kept on improving the product. So that's the first stage, right? The introducing the product to the market. So what I would say about that is the most important thing is piloting and testing, right? You want to get a piloting customer who actually needs the product and relies on it, because that's the only way they're going to give you great feedback. And naturally, with that, the product will grow, and it will get into the growth stage, right? So in the growth stage is where the popularity of the product is growing. In our case, that is expanding it to other customers or other solar companies that are willing to try out the product. And so that I think that started maybe after an entire year. So we spent an entire year what you probably call the introduction phase. And we've been in the growth stage right now. So the growth phase, like I said, is where the product is getting more and more popular in the market. And so far, we've accumulated about 20 customers, some within our country and some in neighboring countries. So we've had customers in Kenya, some in Tanzania, some in the DRC, some in Somalia, Ethiopia. And these people enjoy the product, they've used it, it works for them. I would like to say that we are still in the growth stage because ourselves to be in the maturity stage, right? In the maturity stage where our product, we don't spend that much on marketing, or we do not put that much effort into product development or R&D for the same particular product. Maybe we'll be expanding the product line, but not necessarily changing that much on the product. And I hope that the decline stage, which I think is the last stage, does not happen anytime soon. But so just to tell you where we are right now, I think we're in the growth stage because we're still investing a lot of money in marketing, and the product is not as popular as we'd like it to be. So that's what I'd say about the product life cycle. And of course, well, another thing I can add about the life cycle is the growth stage, of course, is the most important because it's what catapults you into maturity stage. And in the growth stage, your task as the maker of this product is to make it as good as possible. So everybody who has an iPhone swears by it. So can your product be as good as that? People who drive the Tesla Model S now swear by it. So that means that they've probably reached the growth stage as well, probably even exceeded that. So I would like to skip over to something else. So local assembly, again, here I'll share my experience with local assembly. Our product is locally assembled, although of course we're based in Kampala, Uganda, and in Uganda you don't have that much going on in regards to manufacturing and fabrication of high-tech electronic devices. Our device is an IoT device, so it's got resistors, capacitors, microcontrollers, and it's got an enclosure on a PCB, and there's nobody that does that kind of fabrication in Uganda. So depending on your locale, of course, your assembly, you will have to, apportion your assembly in different places, and maybe the local assembly is reduced. So in our case, our product starts with a PCB manufacturing, and then the PCB assembly where the components are placed onto the PCB. And both processes have been done in China in the past, from the beginning up to the middle of this year. We'll be relying on the Chinese to do the PCB manufacturing and assembly. So these printed circuit boards come into Uganda already assembled, and then what we do is we put them into the enclosures, and then we program the firmware onto them, and we test them, and then we sell them off, right? So it's maybe like a 20% component of the full assembly of the product that has been occurring locally. However, we were able to secure a grant of about $220,000 last year, actually towards the end of 2019, which was basically enabling us to explore the option of full local assembly. And as we speak right now, we have received the equipment that will enable us to do the assembly of PCB, meaning that by the second half of this year, we will only be doing the PCB, printed circuit board manufacturing in China. However, the assembly will be happening here. So we have made a small leap by taking back a little bit of the assembly. Although right now we do not know how cost effective it is. We might find out by the end of the year that, hey, it actually doesn't make sense for this assembly line and this product, for this assembly line to only be producing this product, because the numbers, like for instance, the assembly line can do about 300 units a day, but we expect to sell 300 units a month, you know, so it might be a bit too extravagant to have an assembly line here. And in that case, then we may have to revert back to what we were doing before. So with local assembly, you need to figure out what makes sense financially. Everyone would like to assemble their product from start to finish, of course, because you want to control the process, and that gives you more control of the quality. But if it does not make sense financially, then you're not going to do it. At least what's important is the final bit, which is the testing and the firmware uploading onto the device. So what I would say about local assembly is, if you have a product, you should try as much as possible to produce it locally. But if it does not make financial sense, then of course, you know, you have to be willing to let other people do certain bits of the assembly for you. And then lastly, e-waste. So what happens with our product is, of course, we assemble the hardware, we sell it to the customer, which is a solar company, and they will install it on a solar system. But of course, this is an electronic device. It's not supposed to work forever and ever. So obviously, it in itself has its life cycle. There will be a time when it will not be functioning. And we have only been in business for about 5 years. We've only sold about 1,000 units of hardware so far. And so because we've only been in this for like 5 years, we don't have any product out there that has outlived its relevance. So we have not yet been confronted with the reality of what happens to this device when it's no longer in use or no longer needed, or it's defective because it's worked for too long and it's given up. However, we have kind of thought about it, and we have been exploring different ways of handling that e-waste, because that's technically what our product become, e-waste. What we're thinking is to develop a mechanism in which we collect out-of-use hardware back at the office, and we want to do this even before we think about investing in an e-waste management system. So the first step is, how do you get back the e-waste, right? So we're thinking of collecting back e-waste, because I'm thinking when somebody purchases a solar system with a monitoring system, they want that to be there all the time. So if the device that they have is too old, they might want a new one. So it will be easy for us to collect the old one, and we can pile up the old ones in the meantime until we're able to invest in an e-waste management, or we can partner with somebody else in our locale who has some kind of e-waste management system where we can maybe reclaim some materials or put everything to good use. I mean, part of the grant was also getting injection molding equipment, and our enclosures are plastic, so we can definitely recycle the plastic enclosures. The printed circuit boards are the more complex part, but I think there are ways to deal with that as well. So yeah, I think in that short time I've given you a rundown of my experience with the 3 items on the topic. Thank you.
Thank you very much, David. We will have some time at the end for some questions. So I encourage all the attendees to start writing your questions in the chat box for David or for all the other panelists. And now I want to give the floor to Laura. I will be changing the slides for you, so you please let me know when you want me to change your slides.
Brilliant, thank you. Can you hear me okay? Brilliant. So hi everyone, I hope you're all doing well and that you find the talks today useful. So my personal interests lie in low carbon energies such as fuel cells and batteries, as well as increasing energy access to ensure as many people as possible have access to secure, affordable, sustainable energy. So Acceleron share these values and we produce lithium-ion batteries with the circular economy in mind. Could you just go to my first slide? Is that available?
Has it moved?
No.
Sorry, just give me 1 second.
Oh, that's moving now. Yeah, perfect.
Okay.
Thank you. Thanks. So batteries are a great option for increasing energy access. Their ability to store clean energy means people will be able to use their energy day and night. So for example, with solar energy, it must be used immediately as it's typically produced during sunlight hours, so unless it is stored, which the battery can do. And the incumbent battery technology here was typically the lead acid battery. And while these lead acid batteries are cheap and sustainable, they're also about 100% recyclable, which is obviously fantastic. The lithium ion does have many benefits over these lead acid batteries. So they're typically more lightweight, often up to a third of the weight for the same capacity available. And the lifetimes are far better, meaning less interrupted supply. And it can also reduce the total cost of ownership for the owner. So additionally, although lead acid is almost 100% recyclable, as I just said, there are issues with recycling of those lead acid batteries, and recycling plants across Africa are bringing issues such as low to mid cost practices, such as backyard and low standard industrial smelting, have low lead recovery rates, and they're, most importantly they're very polluting, particularly to local people in that area. And whilst there is the alternative of high standard industrial smelting, the costs and both the install costs and the operational costs are making that not competitive. So currently it is slightly difficult to recycle those lead acid batteries. So moving on to lithium then, which is what we produce, many people are moving across to those batteries, excuse me, and they are much more expensive. It's often outweighed by those benefits I just mentioned. So the major problem with these lithium ion batteries is their recyclability. So as it shows on this slide where we're talking about here, there's not currently any recycling methods in Africa, other than sort of really small demonstrators, and there's also none in the UK really either. So all the battery recycling would typically need to be shipped to Europe. So obviously this would then rely on high and fluctuating logistics costs to move the batteries to recycling. And so one of the reasons for this is the method of recycling is much more difficult for lithium, and the materials involved hold much less value than, for example, the lead coming out of the lead acid batteries. So therefore reducing the economic reasons behind the need to recycle. So the number of electric vehicles and batteries for energy storage increases. We must consider the batteries at their end of life. So one of the figures is that by 2040, there is expected to be around 44 million EVs on the road every year. And that alone would produce 22 million meters cubed of battery waste. And there's some examples on this slide to help you visualize how much this. So, and as England are playing India in the cricket today, I'm going to use the Melbourne cricket ground as the example. And at 1.5 million meters cubed in that cricket ground, we'd need 14 of those to contain that waste, which is, and that's literally only the EV vehicle waste, and it's not considering the large amount of waste expected from the home energy storage and other applications such as light mobility. So if you wouldn't mind just moving on to the next slide, please. Thank you. And so this is where Acceleron comes in. Our battery design is built with the circular economy in mind. So unlike traditional methods of assembly, where all cells are welded together within a pack, and if a single cell or a number of those cells go wrong, the entire pack would need to be thrown away. So our patent, Acceleron's patent, lies in our non-permanent assembly method. So we actually use compression to put our batteries together. And this allows us to maintain and service our batteries over their lifetime, and that really extends their lifetime and reduces the waste, and also can reduce the total cost of ownership for the customer as well. So we are able to use this technology both with first life cells and to produce brand new batteries, which we sell in the UK, Europe, the Caribbean and Africa. And we're able to use that design as well to repurpose second life cells. Just go to the next slide, please. Thank you. So the needs for battery customers vary greatly depending on their market and the use case as well. So we produce different batteries and different business models for those markets. So we've worked with some great partners to do this as well, to deliver projects over the years, such as Total, Tata and Bbox, and a couple of others are mentioned at the bottom as well. So the ability to upgrade our batteries as new cells come to the market, as well as their maintainability, means that they work very well for such markets as data centers, typically where they would need to install a solution which will work for years to come. So we're able to place batteries in an energy as a service model as well, or ESAS as a lot of people call it. And that allows us to provide solar home systems for a small monthly fee, allowing greater access to energy for those who can't actually afford the capex up front. And finally, as I mentioned, we're able to test and repurpose batteries which come into the waste stream. So if you could just go to the next slide again, I'll just quickly go through the process of that. So this is our process in Kenya that we work towards. So we work with the WE Centre there. So they're a waste centre that typically take in a lot of different e-waste from across Kenya, based in Nairobi. And so they're initially collected and sorted, and then we move forward into the final disassembly of those initial battery packs. And we can then check, if any of them are particularly rusty or look bad, then we wouldn't necessarily test those as they can be dangerous. And so any cells that pass through that initial stage would move forward to the cell testing stage, which we look at voltage, internal resistance, and they go through a full charge and discharge cycle, which the data from then goes into algorithms to ensure whether they can be moved forward and put into a pack for a second life. And then these cells are sorted and grouped, and then they would be placed within packs and then can be sold on. So that's just a little bit about that process. I think that's kind of all the slides I had, but I just wanted to talk about some of the issues that we see as a company, and hopefully that might provide some insight into things that you could do as part of your challenge and things to consider. So we, as I mentioned, we're doing that process in Kenya now, and we've been doing that for the last few years, and we're currently expanding that process into Rwanda as well. So as with all businesses, there are many challenges to overcome, and they really depend on geography and market. So sticking to Kenya for now, I'll mention some of the issues we've faced there. So as it's batteries, the safety is a really big one, and it must always be considered. They're able to explode or cause fires, particularly when not handled correctly. And so while this must be considered for staff safety in the business, it also must be considered for the customer as well. So things to consider there is that, you know, the batteries must be really well contained in a box, because typically if somebody can open a box, they will. And if that could happen, then, you know, they could move things about and cause an injury. So there's just there's a lot of risk assessments, and fire and safety equipment is required, and that's all, you know, highly costly. So that's just one of the big things to consider there. One of the other challenges we've come across is the cost of poor quality first life batteries, which are on the market, and generally they're built with poor quality cells, and they would last maybe 1 year or only slightly more. And the market acceptance of something termed second life, which is what we do, is, you know, it kind of has a negative thought in some people's minds. And so we've actually done studies to show that our second life batteries are frequently much better than the first life batteries on the market. So just getting that across to people and getting rid of that public perception of second life and waste is kind of one of the key barriers to entry to the market. So then just quickly going back to safety, the certification of batteries is actually a really good way to ensure the safety of the battery products. And typically any battery sold in the UK must go through a certification, and that's done by an external body. Unfortunately, that's still really difficult with second life batteries, and the standards are not quite there yet. And so it really means that the onus is on the company themselves to ensure that the product is up to a good standard and won't cause any safety issues. Excuse me. So then again, because of the second life nature of our products in Kenya, and the supply chain is really important, and it's often a challenge. So it really depends upon the stable supply of those waste cells, which we can use to produce those products. And as I mentioned, we work with the waste centre there, and they've been absolutely fantastic in ensuring that we do have that standard and reliable supply of cells. But a supply chain that is reliable is always something that needs to be considered to ensure that you have that product at the end of your production line, so that it is able to be sold when you expect to be able to sell it. And then just moving on to logistics, it's difficult for a few reasons, particularly for us. Batteries must be shipped under dangerous goods, and so that obviously increases the cost, but even more so because of COVID at the moment, the shipping costs have really been pushed up, and just increased the timescales. So as you can imagine, that really impacts business models. If you expect to be able to ship to your customer for a certain price, and that fits well for them, and that would typically be your business model, but this just really brings in an external factor that you can't necessarily control, and so it's just things like that, those type of risks that need to be considered, really. And if you're able to consider anything like that, then that's fantastic. And then just finally, I just wanted to mention that if you're able to have that local supply chain, that's, you know, a really good way to go. Local people tend to know the market and the area much better, and so it would give you a running start. So then hopefully as a business you could repay that by providing training and jobs to the local area, and therefore typically increasing knowledge as well. And if that local area and local supply chain is possible, it's really useful to try and consider gender equality in any roles, really, because as we all know, females in energy and tech and engineering is quite rare. And so if you are able to consider that and make a positive impact of how to get more women involved at a younger age through workshops, or, you know, just even in your hiring processes, if you can try and hire women there, then it's a really good first step, and hopefully we can make it a more gender neutral workforce. So hopefully I've covered a few areas there that you can consider, but yeah, that's where I'm up to. Thanks.
Thank you very much, Laura, especially for that last remark about gender balance, gender equality, etc. It's super important. We will have some questions after the next speaker. So just a reminder to write your questions on the chat. And now, Biraj, the floor is yours. If you can join us, because I know that you are having some technical problems. Hopefully, all solved, and you can unmute yourself and share some of your expertise. Biraj, are you there? I think. Hello, Biraj. Yes.
Hello.
Hi, we can hear you, but if you are having problems, don't worry about the camera. No, now you went offline, I think. It's challenging these days with all the internet technologies. Okay, well, while we give some time to Biraj to join us again. Hi, we can hear you now. Biraj, we can. Well, actually, we can hear your phone call ringing, but we can hear you. Yes, go ahead. Can you try
please
to?
Hear me?
We hear you.
Hello.
Yes. Yeah.
Okay. So I'm so sorry. So I have a bit up and down this internet. So thank you, Jacqueline, for giving this space here, and also it was great to hear David and Laura. So unlike them, so I represent from NGO, so we are not any manufacturing companies. So we are more into like use of their products to our communities. So as Jackie said, my name is Biraj Gautam. I work with People, Energy and Environment Development Association. PIDA is an NGO based in Kathmandu, Nepal. We are working in energy sector since 1997. PIDA mainly works in the areas of energy and environment, but our special focus is in renewable energy technology services to the underserved communities in Nepal. In the past, we have been working many renewable energy projects, such as solar-powered water lifting projects, electric cooking projects, solar-powered cold storage facilities, in the community, so small scale 5 metric ton, and community electrification projects through the use of solar and wind hybrid projects, and also micro hydro projects in various parts of Nepal. All the technology except the micro hydro, we have been importing those technologies from abroad, either from India or China or other countries. But we do have mixed experience with the imported technology during the post-project phase because of not having local expertise in the country. That's why in today's discussion, I would like to share about not having the local manufacturing facility and also capacity of repair and maintenance in the post-project phase. So my focus will be a little bit with the electric cooking project that we are doing in the large scale at the moment. So to give you a little bit information about the current context of Nepal. So do you hear me, Jackie?
Yes, we can hear
you. So currently around 92% of Nepalese households do get the access to electricity. With the increasing number of households having connected to electricity and country moving towards improving quality of electricity, Government of Nepal and number of other organizations like PETA are working to promote electric cooking in Nepal. So the promotion of electric cooking is in very early stage, but the government has targeted to ensure 25%, which is roughly around 1.5 million households, start using electric cooking as a primary cook stoves for their cooking by 2030. Our previous study had found that electric cooking devices are being liked by the users when they were supported with the required knowledge and education on the use and benefit of such stoves. Following the acceptance of e-cookers by the community and the campaign by the government to promote the electric cooking will surely increase in the demand of such stoves. But ironically, all the cooking stoves and cooking devices are imported from foreign countries. So we don't have any manufacturing units that manufactures electric cooking stoves. In other areas also, we do not have that much manufacturing capacity. But since this electric cooking stoves we want to promote in large scale, but still we don't have any manufacturing facility. So the important technology has its one benefits and also bad sides of it. So high cost and complexity of overseas developed and patented designs of equipment may prevent this widespread implementation, especially in low-income countries like Nepal, where the need for such converters is high to support development efforts. Solutions that are
I think we lost you there, Viraj. We can hear you now. No, I don't know if it's only my problem, but I cannot hear you, Viraj. No.
Yeah, sorry. For example,
Yes.
the current technology we have been using are mostly made for the abroad things. Like, for example, they don't have some sort of features that helps us to cook roti, that is the local food and all these things. So those kind of things can also be addressed when we can do the local manufacturing. To overcome these challenges, system and products must be able to be manufactured using local industry, enabling a local knowledge base to build and provide low maintenance, repair and end-of-life services. The use of shared knowledge, sometimes referred to as commons within local workshops, enables products to be designed globally by a team such as yours, like the students and the professors that now are engaged in the field. Technology transfer to the country-based manufacturers to make prioritized sector resilient, sustainable, and jobs provider in the country. So we believe like 3-step support solution can help in the establishment of the local manufacturing. So understand the local context. So first, before we design anything, we try to understand the local context. Then develop a design and connect with the local manufacturers to connect the products. Then do some local research and field testing phases to ensure the product is suitable for the applications. So in this part, the students can be connected, as Laura said, local community engagement organizations such as PETA and other organizations. So I would like to give like one of the examples how we faced difficulties when we did the electric cookie stoves project in the past. In one of our research projects, so we did some laboratory research and we found that 1 kilowatt capacity was sufficient to cook most of the Nepalese foods. But the induction cookie stoves that we wanted to use for that research had 2 kilowatt rating. So all of the induction cookie stoves that we find in Kathmandu is like 1.8 to 2.3 kilowatt rating. since the 1 kilowatt is sufficient and we wanted to do these things in the weak grid and a micro hydro mini grid, that means if we bring unnecessary power consumption in those grids, then that can hamper the quality of the mini grid. Sometimes it can also affect badly to these mini grids. That's why we wanted to use like 1 kilowatt system. Then so there was not any product that was available in Nepalese market, and we can modify that to 1 kilowatt. Then we had to import those products from India, especially for this purpose. And they came and we modified and we sent it to the community. So they worked well for some time. So after like few months, couple of products, they were broken, so it was not working. And then suddenly, like people who were started using the electric cooking, so like clean cooking, then they had to go back to the traditional way of cooking, means the firewood cooking in the firewood. So it gave like a little bit bad feeling to them, and also there was some sort of problems for the community to repair those things immediately in the local area. So for this particular project, PITA could help those products, bringing them back to Kathmandu, the capital city of Nepal, and fix them and send them back to the village. But we think this is not a sustainable solution for the longer term. So what we believe is ensuring a repair and maintenance facility in the local level is also a most important issue to consider for the sustained use of the technology. So for this, we can develop a simple repair and maintenance manual while developing the product. We can make the process simple and ensure the parts are available readily. And
I think we lost you there again, Viraj.
I'd like to say is, so just give the emphasis to understand the local context while designing the product. And if possible, do connect with the local manufacturing companies to ensure the local manufacturing, and also do trials locally to ensure the product is suitable, and provide some sort of operation and maintenance guidelines when these products go to the market, either commercially or for the testing phase. And that can ensure the use of product and also demand of the product. So these are the some of the things I wanted to share with you from our experiences in the field. Thank you for listening, and I'm sorry for the interruption and quality of my internet. Thank you.
Thank you, Viraj. Thank you very much. We overcome all the issues with technology, so we could finally hear you very well. Thank you very much. So we are having some questions on the chat. So let's move to the Q&A section, and please feel free to ask more questions. So the first question is for Laura. Manasa Maladi, hopefully I pronounce it properly, is asking how much are the Aceleron batteries? I guess he's asking about the cost. Is there anything you can share there?
Sorry, I was muted. Yeah, of course. So we sell in, as I mentioned, a few different business models. Our first life batteries that we sell in the UK and the Caribbean, mostly, they're sort of the mid to high range of the market. So we're not the lower cost batteries that I mentioned. And that's simply because they are good batteries, and they, as I said, they can really have extended lifetimes. But we don't quite have the really the marketing and the brand knowledge to enable us to go to sort of the really high rates that people like Tesla and things put their batteries out there for. Our second life batteries, we're doing quite a large piece of work on this now to really understand where the market is for those prices. What we are trying to do is be really competitive with those first life batteries that I mentioned from typically from China that are coming in, and that's so that we can provide good batteries at a price that is going to be acceptable to the market and that people can afford, basically.
Thank you.
Hopefully that question.
Yeah. Hopefully yes. If not, please, Manasa, send us a chat. Next question is for Viraj from Surjadip Basak. Is asking for the electric cooking. So how difficult was it to convince the locals to shift from conventional cooking to electric methods? And the second part of the question, well, or comment, is that they are developing an off-grid solar power green flooded system, and their concern is to create market demand for the product. Is there anything there you can share, Viraj, if you are still with us? I don't know if you can hear us, Viraj, but you are muted. Okay, we will share this question with Viraj via email, and we'll get back to you, Surjadip, with an answer, okay? And then let's move to another question. How do you see the impact of interoperability between different appliances and the systems on reducing e-waste? I don't know who wants to take this this question, David or Laura.
I imagine David might have some with his IoT.
Sure. Yeah. So yeah, I'm a little bit familiar with the interoperability thing. So of course, if what you mean by interoperability is basically different systems within the same ecosystem being able to interconnect, hence so let me just give an example, okay? If you're using a Samsung phone and say you're using and then you buy then you maybe there's something happens in Samsung and you buy an iPhone, right? You buy an iPhone, you might realize that, oh, if you know to have a very good experience with the iPhone, I have to get a Mac, right? And then you get the Mac, and then you realize, oh, I think you know I need to get like I need to get an Apple Watch to get a full experience. Now, on the opposite side, if you're using Android, you can use any kind of laptop, any kind of Android phone, any kind of general Android watch, and you would still get the same functionality, maybe not to the same quality, but you get the same functionality. Now, the difference is that if you're using an iPhone setting, so you're using the iPhone system, or if you're using Apple stuff, right? You need a full set of Apple stuff to get the kind of functionality that you want. Using stuff and something happens to the Android watch, you can buy another Android watch and it will work with the Dell laptop and the Samsung phone or Techno phone, right? So of course interoperability does reduce e-waste because you don't have to replace a lot of hardware, right? You can replace different bits and pieces because whatever you get, the replacement you get will be able to work with what you already have, right? So you can replace one piece at a time, and whatever piece that you choose to replace in your system of operation will still work with whatever else was there. Whereas, you know, if you're using a certain system where things are not interoperable, in which case you have to buy a full set of something, then if something in that set becomes obsolete, you're tasked with replacing the whole set, and hence the entire obsolete set is e-waste, right? So I don't know if I've done a good job of showing the difference, but I think it does arrive to the conclusion that interoperability does reduce e-waste, for sure.
I think, yeah, just to quickly add to what David said there. So taking his example, if, for example, you had a few different methods of say cooking, or and the actual connection there would be to say quite a standard connection to either solar panels or to a battery, then that could be a really good option to reduce the e-waste in, you know, the need to replace the entire cooking system because the battery or the method for powering that has failed. And so, yeah, there's the opportunity for reducing e-waste there as well.
Thank you. We are running out of time, but there is one question that maybe you can answer very quickly. In your opinion, is zero waste a pipe dream or is something that is feasible? And if feasible, what needs to happen to achieve it?
I'm off mute, so I'll take it quickly. So I think it's hopefully not a pipe dream. Zero waste is going to be incredibly difficult, and so I think we need to start now and start as quickly as possible, and do what we can. So, and particularly for countries such as that are developing and don't necessarily have that access to energy already, it's really important that we start with the sustainable energy, which I think hopefully it could happen and is achievable. And so, yeah, that's my 2 cents.
Thank you, Laura. Viraj, it was a question for you, but you were offline. So the question is, how do you convince the local to shift from conventional cooking to electric cooking? So if you can very briefly give some tips to this team that is working on a solar off-grid power system. I think you are muted. We cannot hear you. No, we can't. I think you are unmuted, but we cannot hear you. So maybe some problem with the microphone, but don't worry. We can share the question with you, Viraj. No, we cannot hear you, sorry. I will share the question with you, Viraj, and we will answer the question offline through the email, if that's okay. Because we cannot hear you, sorry. IT problems, don't worry. Big thank you to all the speakers and the attendees for being here today with the different time zones and with all the busy schedules that you all have. Thank you very much for being here. And now we value all your feedback and we are very keen to hear from the opinion of all the attendees and assess this webinar. And this will help us to improve for future webinars. So we have prepared a very short survey that will take less than 1 minute and will pop up right after the webinar. So if you can just wait 1 minute and help us improve. Also, at the, otherwise, yeah, we will share later on with the recording the survey. And at this point, I just want to remind that a recording of the webinar will be available on the Efficiency for Access Design Challenge website in case you want to revisit some of the examples and interesting information you have listened here today. And we have 2 other webinars in March and April, one on affordability and a second one on unintended consequences of the growth of the sector. You will soon receive an invitation through your academics, but you also have the links to register on the last Efficiency for Access Design Challenge newsletter. So if you haven't received it yet, you can sign up in this link that it will be posted on the chat box also. And now, yes, thank you very much for all being here. Hopefully you've learned something today. I've done, and thank you very much. Have a nice day.
Thanks, bye.
Cheers.